Hello, everybody, and welcome to SQL on the Edge. This is episode 16, and we're going to talk about Cosmos DB consistency models. I'm Warner Chavez, SQL Server MCM and Microsoft Data Platform MVP, and I work at Pythian. Make sure you visit us at pythian.com. So the topic for this short video and demo of today is Cosmos DB consistency models. Remember, the different consistency models are basically a way to do trade-offs between fidelity or latency. We can have very truthful data with like strong consistency, but this data will probably have higher latency and less availability. We can also have other data and like say eventual consistency, but eventual consistency will not be as truthful as strong consistency. However, on eventual, we will probably have very low latency and higher availability. So as you can see, it's mostly a way to check whether you want to do a compromise towards the fidelity part or towards the latency part. Now, the interesting thing, of course, is that Cosmos DB didn't just go with strong and didn't just go with eventual. They implemented several in between consistency models. And you can check out the blog post that goes with this video to look into the details of what those other consistency models are. Now, you might be asking for yourself, well, why can't I just do everything strong? Why do I even have to worry about consistency models? Well, remember, Cosmos is a distributed database where you are replicating data to many different nodes. And also, Cosmos was built with the idea of doing planet scale geo-replication from the very beginning. So it was very important for the team to give developers the tools that they can use to tweak those consistency models and get better latency or higher truthfulness depending on their requirements, even though the database can be replicating over very large geographic distances. Okay. Last bit that we need to understand is that the consistency model also has a direct impact on request unit consumption. If you don't know what request units are, there is also a SQL on the Edge episode, I believe it's a couple of episodes behind, where we talk about the Cosmos DB request units. Okay, so let's check out the demo. We're going to look at how you can change the default consistency model of a database. We're going to check how you can change it in the code, and then finally, we are going to do a demo to show the difference in request units depending on your consistency model. So let's go check it out. Okay, so I'm in the Azure portal right now, and I'm already located at the blade of an Azure Cosmos DB account that I already have. And I'm just going to show you real quick how easy it is to change the consistency level, the default that you can have at the global account level. Okay, so as you can see here, I'm just going to go down this left panel, and there's this option here that says default consistency. You just have to go on it. And then here we can select the different consistency levels that we can have. So you can see I have strong, bounded staleness, session, consistent prefix, and eventual. And right now I have bounded staleness selected. We can also see at the bottom, for example, for bounded staleness, it's configurable. So I can have a maximum lag of operations, and or I can have and also a maximum lag for time. In this case, you can see for my setup, I have it set a maximum lag of 5 minutes in a bounded staleness default configuration. Okay, so this is how you can change it at the default global level in the Azure portal. So a couple of clicks and you're done. Now I'm going to go and show you in the .NET library how you can do the same thing. So this is a command line utility that I have, and I can receive the consistency model through the command line. You guys can see here I just have a very simple switch case statement, and if I type in the default, then it just doesn't specify the consistency level. Otherwise, it passes on the consistency level that I want as a parameter to the constructor of the document client class, right? Very, very simple. You guys can see here, it's an enumeration there at the very end. It has consistency level dot, and you specify which one is the one that you want. Once you have those configurations for the client, the endpoint, the account key, the connection policy, and the consistency level, then we simply do an open operation on the client to initialize our connection. So very, very, very easy to work with here in the code to change your consistency level at the client level if that's where you want to override it. Now, finally, I'm also going to open a copy here. I'm just going to go and press start. So we're going to have my demo application running, and we're going to test out the impact for request units of Cosmos DB's different consistency levels as well. Okay, so I'm just building my solution right now, and then we're going to connect to it, and then we're going to do a very simple workload of a read query to see how it impacts the request units. So here I have my utility running. I'm just going to say I want 3 machines, I want to do 3 calls per second, and I want to do, let's say, 3 iterations as well. Now you guys can see here I'm going to do a status command, and if you see right now here, my consistency level says bounded staleness, right? So the same as I had in the portal is the same as I have right now on the client. So I'm going to run a read workload, the one that we just configured. Just going to go with start read. And then we're going to see how many request units we consume, right? So we consumed for pretty much every iteration about 33.12 request units, right? Now I'm going to override this consistency, even though remember on the portal the global default is bounded staleness. I can override it here on my client. So I'm going to switch here to a consistency level of session, okay? And then we're just going to rerun this same workload, and we're going to see the impact here on the request units. As you guys can see there, we went from consuming 33.12 to exactly consuming half of those request units. Now we're consuming 16.56. That means that if you are okay with looser consistency levels, you can fit double the amount of operations with the same cost of request units. So it's very critical for a really well-managed, resource-efficient Cosmos DB database that you really use the consistency level that you really need, and not just go by default using strong or bounded staleness, because those will be more expensive in terms of request units. Okay, so I hope that gave you a good overview of how consistency models work and the impact they can have on your request unit consumption. It's very easy to change the default. You don't even have to do it in the code. The default, you can change it in the portal with just a couple of clicks. In the code as well, though, as you saw through the .NET library, it is very easy to manipulate as well, and you can do it at the client or even at the individual query level. As we saw, strong and bounded staleness have a higher request unit consumption than some of the other more loose consistency models, such as session, consistent prefix, or eventual consistency. Those will actually cost half the amount of request units compared to the two more strong consistency models. And then finally, you need to understand this if you are a developer for Cosmos DB, because depending on the operation that you're doing, you will want to use a different consistency model to really get the scalability of the system that you want, especially if you're going to go with a geo-replicated type of system. Now, if you are doing an operational role or an administration role, even though Cosmos doesn't have a lot of administration, but if you do are taking the responsibility for it in that sense, then you also want to understand them, because you have to be able to speak that same language with your developers. Okay, so up until next time, I hope you got a good idea of Cosmos DB consistency models. Stay tuned, and thanks for watching.